Ice protection on the Q400 consists of de-icing to remove already formed ice, electrical anti-icing heating to prevent ice build-up, and an ice detection system to give early warning of icing conditions. Airframe Ice Protection uses engine bleed air from the pneumatic system to inflate de-icing boots on the wing leading edges, on the engine nacelle air intake lip, on the horizontal stabilizer, and on the vertical stabilizer. Electrical heating from the 115-volt variable AC supply is used to de-ice the propellers, to anti-ice the engine air intake flange, and to anti-ice the pitot-static probes and the angle of attack vanes. The windshields and the left pilot side window are also electrically heated and demisted. The ice detection system consists of the left and right ice detector probes and windshield wiper ice detection lights, which reflect back from the windshield wiper spigots. The ice protection panel on the overhead panel contains most of the controls. Because you're looking up at it, you should imagine that you're viewing the aircraft from underneath. So this is the left wing, and this is the right. On the panel are controls for automatic boot sequencing and manual sequencing, for prop heating, for electrical heating of the engine intake flange, and for probe heating. The windshield panel controls the windshields, the left side window, and windshield wipers. Just below the steering wheel, on the left side panel, is the alternate wiper push button. When pushed in, the left pilot windshield wiper operates at high speed. On the left and right side panels are buttons to shine an ice detection light which reflects back from the windshield wiper spigots. There is also a de-ice dual pressure gauge on the right side panel, showing pneumatic pressure in the left and right boot system. These caution lights are used. Now the ice detection system. If one or both ice detection probes detect more than 0.5 millimeters of ice, you'll get the ice detected message near the bottom of the engine display. With the prop off, the message will flash in yellow to get your attention. With the prop on, the message was white in reverse video for 5 seconds, then normal. This is the situation with the ref speed switch off. With the ref speed switch set to the increase position, you get the increase ref speed message as a reminder, and the stall protection system increases the stall margin to compensate for suspected icing conditions. If ice is detected, you'll get the message, but this time it doesn't flash. After ice is detected, the probe is electrically heated to clear the ice buildup, so that it can detect ice again. If both probes fail, you'll get the Ice Detect Fail caution light. Failure of just one probe is recorded in the engine monitoring system, but not announced. Airframe boot de-icing. The boots are connected by pneumatic lines supplied by engine bleed air through 6 dual distribution valves. The left and right sides are normally interconnected, so one engine can inflate all boots. However, if you suspect a pneumatic leak, one side can be isolated at the isolate valve by setting this switch to the isolate position. On the side panel gauge, check that left and right pressure are the normal 18 psi. With the boot air switch in isolate, the pressure readings are for each side. With the switch in norm, the readings are for the combined manifold. Watch out for the low pressure caution. The boots are not inflated with air at the same time, but in a sequence. controlled by a timer monitoring unit in auto mode, or in manual mode by the Airframe manual select switch. In auto, at the slow position, the boot inflation time is 6 seconds per boot combination, and the resting time at the end of each sequence, known as the dwell time, is 144 seconds. This takes 3 minutes for a full cycle. But at the fast position, the dwell time is only 24 seconds, and the cycle takes 1 minute. The timer will not do a part cycle, so moving the selector to slow or fast, then back to off, will initiate a whole cycle. Just for interest, here's the fast sequence speeded up. If there's a problem with the automatic timer, indicated by the De-Ice timer caution light, or if there's a problem with the isolate position of the boot air switch, use the off or manual position of the mode selector. Both have the same effect. Then one of the select positions of the Airframe manual switch. Each propeller blade has an electrical heating element covering 70% of the leading edge of the blade. Power is from the 115-volt variable AC system, so prop speed must be above 400 RPM. When this prop switch is on, and total air temperature is below +5 centigrade, all 6 blades on one prop are heated simultaneously, illuminating a prop's light, followed by all 6 blades on the other prop. The on and off times depend on total air temperature and are controlled by a timer monitor control unit according to this table. Again, the left and right heating and dwell cycle will complete if you switch off the prop heat switch. In the test position, each prop is heated in turn for 5 seconds, followed by a dwell time of 30 seconds. There are protection panels on the fuselage to prevent damage caused by ice thrown from the props. The prop de-ice caution will come on if there's a failure in the system. The standby, number 1 and number 2 pitot-static probes are heated when these switches are on. Number 1 and 2 by 115-volt AC and the standby by 28-volt DC from the right essential bus. The caution lights come on when a probe is on but not powered or is switched off. The angle of attack vanes are continuously electrically heated and there are no flight deck controls. But if there is a heating failure, the associated system stall fail caution light and the stick pusher caution light illuminate. When the engine intake bypass doors have been opened with these switch lights, the heater segment comes on automatically at outside air temperatures below +15 centigrade, indicating that the primary and secondary 115-volt AC heater circuits are on. There's no heating when the doors are closed. If both the primary and secondary heater circuits fail on one side, you'll see an engine adapter heat caution. But if only the primary circuit fails, this is recorded but not reported. Just below the ice protection panel, the windshield panel controls windshield heating, the left pilot side window heating, and the windshield wipers. Windshield heating is also from the 115-volt AC system. The warm-up position provides gradual heating of both front windows from the left AC bus to guard against cracking, but it's not normally used. Norm provides full heating of each front window from its related AC bus. The left pilot side window heat comes from the right 115 volt AC bus. If there are problems, you'll see these cautions, and power to the affected window is shut off automatically. Note that there's only one caution light for both main windshields. As the window cools down, the light will go off. This switch controls both windshield wipers. Moving it from low or high to off will leave the wipers at their current position. Moving to park will park the wipers. There's no windshield washer